Alright, this is part 2 of the path of a packet through the Linux kernel. We're starting at 4.1.3, IP layer. IP processing starts with the function IPQ transmit. First, the function determines a route to the destination. If a route is already in skbuf to skbref destination, it skips the routing process. In this case, the function builds a header immediately. However, if there is no destination, the routing process continues. It determines the destination from the socket field of the skbuf that, for example, is set if the socket previously received an IP packet. If this is not possible, it queries the routing cache, called forwarding information base, fib, a table that is generated from the IP routing table. Eventually, if there is still no route, it returns host unreachable and stops the processing. Otherwise, the kernel builds the IP header if it finds a route. Now, IP options build is called to set IP options. It marks the beginning of the header with the network header field of the skbuf. Next, it triggers the local out stage of the Linux firewall mechanism net filter. Afterwards, destination output calls the actual routing function via a function pointer. Then the kernel calls the IP output routing function for the most common unicast packet. As the routing is complete, the stage is called post routing. It updates the packet metadata and calls the nf-inet post routing hook. It sets skbuf metadata and invokes net filter once again. Furthermore, it fragments the packet if it exceeds the maximum length. You remember MTU? Then, after passing the packet through the nf-inet local out hook, IP output calls IP finish output. It increments the counters for multicast and broadcast packets. It also checks that the skbuf has enough space for the MAC header. The destination MAC address is either cached or determined by the neighbor output function called nay resolve output, nigh as in neighbor. The latter utilizes the address resolution protocol, ARP. In case there is no ARP reply, it queues the packet again. After obtaining the MAC address, the kernel constructs the Ethernet header, adding it to the skbuf. 4.1.4 Ethernet layer. Firstly, dev queue transmit sets a MAC buffer, just kidding, it says MAC header, filled in the skbuf, which is then passed to TC egress. It queues the packet in the queuing discipline. Oh, that's what QDisc stood for in the previous video in that image. Queuing discipline. It's a place for packet. As long as the NIC buffer is filled, QDisc run dequeues the packets from the buffer. After some post-processing and validate transmit SKB, for example calculating the Ethernet checksum or adding VLAN tags, the kernel calls NDO start transmit and consequently adds the packet to the transmit ring of the NIC. Eventually, the NIC's queue may be full. In this case, the kernel stops the QDisc and queues skbuf. Finally, it maps the packet to a fixed location in memory for direct memory access after adding more skbuf metadata. In the last video, we looked at one very similar. It was also for TCP, but over here was the queue discipline buffer. But let's see how this picture works in the context that we're reading here. Dev direct transmit allows circumventing the QDisc, directly writing the packet to the transmit ring of the NIC. Express data path is a use case of this. Eventually, the function notifies the NIC via an interrupt to end the processing and freeze the skbuf. This XDP being a type of network sockets for heavy loads. So anyways, 4.2 ingress path. Now we trace the path of a packet that arrives at the NIC. Until user space applications read it through a socket, see figure 4, most notably, it analyzes the headers to determine the following function call and strips them. So this is at figure 4, they're saying it is a depiction of the ingress path of a packet in case of TCP as described in section 4.2. And I see IRQ here, interrupt request. So a packet comes in, might go to the ring buffer so it can hang out over here. Could go this way as well. Net filter receives will do its thing. Okay, I'll let you go through the rest on your own. 4.2.1.